Hey, welcome to this tutorial. We're going to be talking about side effects on functions on C and how they can have surprising effects when you do unsequenced operations. So let's have a go. Let's dive into it, shall we? So first thing we have to consider is the source code, and then you can see the source code is very simple. All it does is it declares two integers, a and b, global integers, and then it has two functions, f and g. These functions simply return their arguments, except for function f that also changes the state of b. So b equals b minus 1. The function f is said to have side effects because it changes the state of a global variable b. Okay, so and then we're just going to print them off here. So printf statement fa equals blah, gb equals blah, and we're going to call them fa and gb. We're going to call this function the printf statement. Okay, so nothing so fussy about it. Let's have a look at what we get. Okay, so we just call gcc 02 and then we're going to enable warnings, all extra. We're going to enable warnings for this, so no warning, nothing, so it's good. We can run the program and then we can do out, and then gcc tells us fa equals 1 and gb equals 1 and everyone's happy. Yeah, fantastic, go! No warnings, nothing, everything's good, right? Fine. No, I wouldn't be making the video if it was like that. So the weird thing is that if you use clang to do the same compilation, also no warnings appear, but you get a different answer. So as is possible, GCC gives us one answer and clang gives a different answer. Well, this is completely crazy. Okay, the universe doesn't make sense anymore. What is it? If you go back to this to the code, we'll see here that the problem is at the printf statement, and namely this sequenced arguments here, fa, gb. In C, in fact, the function calls don't sequence the arguments. So when you have a function call, printf, their arguments of the function are not sequenced. They are unsequenced, which means that fa can be evaluated first, or gb could be evaluated first. That depends on the compiler, and that depends on a number of things. But it's unsequenced. So it's a very, very dodgy feature of C, in my opinion, and it can lead to different results. Now it's very difficult to trap this, because if you have, of course, it's not undefined behavior, so there's nothing you can do to find this type of errors or type of unintended behaviors. If you have sanitizer to it, you don't find anything. There's nothing to find. There's no nothing. You can put all the warnings you want. If you know of any warning that would trigger this, any flag that would trigger this warning, then let me know on the comments. But yeah, so this is very, very bizarre, and you get different answers depending on the compiler you get. So, and imagine if you got the same answer, you'd never know. With the third compiler you get a different answer. Yeah, there's not much more I can add to this, so see you in a bit. Have a nice time. See you next tutorial. Bye.